Example number 6, we're given f of x is equal to 2x to the fourth minus 7x to the third minus 8x squared plus 14x plus 8. Now let me show you guys something. And even this was the problem that I ran into when I did example number 4. Double check. It's so easy to forget like a plus or minus sign, and there are a lot of steps that we're gonna do on this problem. So I'm just going to double check. 2x to the fourth, yep. Minus 7x to the third, yep. I'm just comparing to what's in the book. Minus 8x squared, yep. Plus 14x plus 8. Now I can't tell you how many times that I've made a minus sign, a plus, or vice versa, and it throws off the whole problem, and then I get frustrated and I get to the end. And what it says is prove that all the real zeros of this function must lie between -2 and 5. Okay? So this has a possibility of having 4 real solutions, right? This has a possibility of having 4 real solutions, which means that it might cross the x-axis 4 times. And they want us to prove that it lies between -2 and 5. A lot of that has to do with, we know what the factors are, and the factors are possible solutions. So what we could do is determine if there's an upper or a lower bound. Alright? And so one way that we could do that is just do synthetic division of these two. So I'm just going to say, do synthetic division of this equation with 5. So I'm going to say x to the fourth, x to the third, x squared, x, and then x to the 0. And then I'm just going to write down the leading coefficients, or not leading coefficients, but the coefficients of each power. And then my constant 8. Drop down the 2. 2 times 5 is 10. Add those up, I get 3. 5 times 3 is 15. Add those up, I get 7. 5 times 7 is 35. Add those up, I get 49. 5 times 49 is 245. Add 8 to that, and I get 253. That's my remainder. In other words, if I were to take this and divide it by x minus 5, that would be my remainder. I'll explain this in a second. Let's do the lower bound, which is -2. Again, I'm going to say 2, -7, -8, 14, and 8. Drop down the 2, I get 2. Now I multiply that by -2, I get -4. Add those up, I get -11. Multiply those, I get 22. Add those up, I get 14. 14 times -2 is -28. Add those up, I get -14. Multiply those two together, I get +28. Add those up, I get 36. So my remainder is 36, and my remainder is 253. Now, what we're really doing is we're proving that 5 is the upper boundary for the x and that 2 is the lower boundary in the real zero. So the function f has a positive leading coefficient. So we employ that the upper and lower boundary test by using synthetic division, which we have done, because the last line, and this represents the last line, and this represents the last line, because the last line right here, they really mean last column. Because the last line in the first division scheme consists of all positive numbers, 5 is an upper bound. Because the last line in the second division consists of alternating signs, it is the lower bound. So this is the upper bound because these are all positive. Now because it alternates, because this is a positive 2, minus 11, positive 14, minus 14, positive 36, this is the lower bound. Therefore, all real numbers of f must lie in the closed interval -2, -5. So in your homework, like problem number 37, you're going to basically do the same thing. So let's look at problem number 37 real quick. Open your textbooks and look at problem number 37. For 37, they say that k is equal to 3, and they give you the function f of x is equal to 2x cubed minus 4x squared plus x minus 2. And they want us to prove that k equals 3 is the upper bound. So now if we look at this example to prove the upper bound, what do we need? All positive values when we do the synthetic division. Does that make sense? We need all, so I'm just going to, basically I'm going to do the synthetic division, making sure that I represent x cubed, x squared, x, and then x to the 0, which is the coefficients of 2, -4, 1, and -2. Do my synthetic division, drop down the 2, 3 times 2 is 6. Add these up, I get positive 2, 2 times 3 is 6 again, 21, 19. Are all of these positive? Yeah. Yes, that's the upper bound. Does that make sense? Now let's do problem number 41, because 41 wants us to do the same thing, but prove that it is the lower bound. So, for the lower bound, we need to have alternating signs. So, for problem number 41, they give us k is equal to -1, and they say f of x is equal to 3x cubed minus 4x squared plus x plus 3. Let me double check that because I was doing 3 things at once. Yep, that's right. So now for the lower bound, I'm just going to do the synthetic division using only the coefficients. So I drop my 3 down, multiply by -3, now I have -7. Does that look good so far? That becomes a positive 7, then we have -8, -5. So I have alternating signs, so this is the lower bound. Does that make sense? Do you guys understand what we're doing there?